Hey everyone, this is lecture 3.1. In this one, we're gonna explore how climate change is affecting us on an individual level and how we've kind of done that to ourselves by putting all that carbon up there in the first place. So, first we're going to talk about how did we get here in the first place. Then we're going to talk about, and basically recapping previous lectures. Then we'll talk about why too much carbon is bad and why this is so hard to understand sometimes for all of us. And who is it exactly that is resisting this change? That is a theme that we're going to talk about later in this course in like a more exacting way, but just a general, why would somebody do that, right? For a lot of us, why would somebody not be an environmentalist is really kind of like a puzzle. But there are people who aren't. So, just to remind ourselves, while our current climate crisis started before any of us were born, right? It really started when we started using internal combustion engines. But we lived for hundreds and thousands of years in a state of relative carbon balance. Sure, ancient Rome did some damage to its surrounding environment, but in general, the atmosphere wasn't affected by that. And then, as I just mentioned, about 250 years ago, then, when we started burning fossil fuels, then that kind of started the problem. And while it was still very hard for people in the 1800s, nobody's saying it wasn't, right? You were putting your life on the line. If you were one of those workers, almost exclusively men, who worked in factories of that era, that intensely hard work was still better than working a farm. Just to keep that in mind too, right? When you are working a farm to survive, that is such a precarious existence that going to work in a factory for sometimes like 14 hours a day, 7 days a week, that actually sounds actually not that bad. This is just kind of a reminder. Yeah, those old factories sounded absolutely hellish, but they actually sounded better to the people of that era who were, for example, not using modern farm equipment, but they were actually scything entire fields of grain like by hand with a couple of other people if they were lucky. So, uh, with that also in mind, then, this adds a layer of complexity to what does it mean to be a modern person, and can you be a modern person without all that carbon? Up to this point, the way we've done it, the answer is kind of no, right? We haven't quite figured out how to not expend a tremendous amount of carbon and live the comfortable lifestyles that most of us live and that we should maintain if we possibly can, right? Hot water is pretty cool. I love to be able to keep ice cream in my house. I am at this very moment in an underground room, wouldn't be able to do this stuff. There's all kinds of things that we should as a society still be able to do. We just have to figure out how to do it in a sustainable way. That is a big issue for us in terms of figuring out sustainability. And then additionally, it's important to keep in mind that the United States, very much to a point, but also especially the powers that were the true colonialists during that era of colonialism, they got to be powerful and developed and advanced during a time when they were allowed to pollute as much as they wanted to, right? So there is a certain question of, is it fair, right? And what is fair? Should the same standard for the United States apply to areas like India, while their technology didn't have that same boost, right? That is the whole controversy that surrounded and continues to surround climate negotiations that India, I don't recall if China does, but definitely India does. Their timetable for being carbon neutral is bumped back about 20 years to the rest of us. And the rationale for that is not because they're intractable anti-environmentalists, but they need that booster time because other areas had it, right? And that's just like a big example right there. But that's to be kept in mind. But then on the other hand, though, does fairness matter? We are talking about a significant portion of the life on this planet, and we're definitely talking about billions of humans' lives, right? What does it matter if we're being fair about it? Is the time for fairness past 100, like when the British colonized India, right? Like these are the ethical questions that are very, very big that I'm not sure, quite frankly, philosophically, as a society, as a species, we have the luxury of being fair. And that is, it's deeply philosophically troubling. And we would definitely, if we were here together, we would definitely talk about that in person. So let's look at, because we've already looked at the fact that there is too much carbon in the atmosphere. Let's talk for a bit about why that's bad. Basically, the effects of carbon into the atmosphere can be broken into two categories. There are primary effects and secondary effects. The primary effects are caused by carbon being put in the atmosphere, right? There's carbon there and it causes this. The secondary effects are phenomena that are linked to carbon excess but are not directly caused by the carbon excess. This includes human behaviors, but it also includes other systemic issues that are created by putting too much carbon in the atmosphere. And I totally get that that might be a little bit confusing of a distinction. Hopefully the following slides will clear that up a little. So the biggest primary effect is global temperature increase. Right now, we are 1.71 degrees Fahrenheit higher than we were in the 1900s. And I don't, that probably is higher. This chart is a little bit out of date. Some places are hotter than that. Some places that are less than that. Some places are actually colder than that. But that is also why we changed the wording from global warming to climate change. We are not talking about everywhere a planet that's hotter. We're talking about an overall planet that's hotter, but all of our ecosystems across the planet are going to be different, and in almost every case are going to be more extreme in terms of extreme weather events. That's what we're going to have. That's going to be the thing that's recognizable to most of us in our lifetimes. And yeah, the heat is going to go up, but the thing we will notice, the thing that everybody will notice, is extremes of weather. And this is yet another area, and later in this lecture we'll talk about it, where it's really hard for us as individual human beings to even notice this stuff, right? That's where climate change deniers get off, quite frankly, is they are able to say, well, no, it isn't. I don't see it. What are you even talking about? Well, yeah, that's because we're not great at detecting it unless we have kind of advanced technology. And if somebody inherently distrusts science because of something they picked up along the way, it's even easier to believe those things. Anything else I missed here? Yeah, global temperatures are definitely on course for a 3 to 5 degree increase Celsius, which in terms of Fahrenheit is a 5 to 9 degree increase. 9 degrees hotter in the summer definitely would be noticeable for real, but the true impact of those temperature changes are, and we all know this by virtue of being in this class already. You knew this before the class, but that's the water increases, right? That's the desertification of previous ecosystems, because ecosystems on this planet and other planets, wherever they are delicate. So those slight differences, they make all the difference. So that slight change then causes sea levels to rise. And that is the direct, noticeable thing. This causes that, right? But then those sea levels rising, there should be a little notation there if you're taking notes in that way. The people being displaced, that's the secondary effect, right? So carbon gets in the atmosphere, sea levels rise, and then people have to go somewhere else. That's the secondary effect. Additionally, this creates ice melt in the North Sea, Antarctica, Glacier National Park, places like that. There isn't ice where ice used to be. It has caused drought in Australia, actually. Australia, since about the mid 1990s, because that was, the outback especially, was an especially precarious ecosystem in the first place, they started suffering from climate change way before most of the stuff, most other people on the planet did. My wife's grandmother was from the outback, and she talked a lot about the droughts in when she was still alive in the 90s and early 2000s, and they were devastating then. And you know, and the wildfires that we now hear of now in Australia, kind of on the regular, they are only fed and caused by that. Additionally, then to go with that, the reason we're having more forest fires is because there is less water in places where it used to be, and thus, once the system gets out of whack, it gets out of whack in all kinds of ways. The Uninhabitable Earth book that is available to us talks a lot about that. Yes, temperatures are rising. Yes, there's going to be more water in places where it shouldn't be, but those things by themselves will create other catastrophes, and some of them that we may not even be able to perceive yet. So another primary effect of too much carbon in the atmosphere, and this is not directly tied to temperature change, is what's called ocean acidification. When there is too much CO2 in the atmosphere, that gas interacts with, and remember, if you from your chemistry, gas is a fluid, right? So is water. They're both fluids, and where they touch each other, that can cause chemical reactions. And by virtue of that, with CO2 interacting with HO2, that creates an acid called carbonic acid. Now, that carbonic acid will not, and this would be beyond the scope of human livability, and this is not going to happen. It isn't going to turn the oceans into acid, right? But it will definitely in some places, hopefully not everywhere, raise the pH value of the ocean itself, right? So when pH values change and your fish live in that water, then that has the effect of, to a certain degree, killing fish, but also killing plant life, right? Plants are especially vulnerable to this sort of thing. Single cell organisms like many types of algae, many types of plankton, the smaller animals, they aren't single cell, but they're really small. That is a big, big danger because unfortunately, a lot of the oxygen in our atmosphere comes from those plant organisms. And additionally, then it also kills coral, which my 6-year-old would point out. Coral is an animal. Yes, it is. Okay, fine. But if coral dies, coral gets bleached, it disintegrates, and then water comes in, and that water coming in then destroys the ecosystems that were behind the coral, and we have what are systemic failures effectively happening. Here is a illustration of what coral bleaching looks like. This is from the Great Barrier Reef. really one of the more magnificent things on this planet, and to go with this, and I fully acknowledge this first portion of the course is a bummer. There's more optimistic stuff that happens in the second portion of the course. The Great Barrier Reef, in all likelihood, will not exist in 50 years because of this bleaching effect. You see in the left-hand side of the screen, in the purpler one is a living, vibrant coral. The grayer one is dead coral. And you can see, well, what matter does that make? Well, in the next picture over of the coastline, you will observe these pocketing of where that little square is, where there were developing coral happening there, and they were getting ready to grow, getting ready to expand. You can see a little bit at the top too, but then you plop over to the other side, that pocketing has gone away, right? That's where the coral was going to spread and grow out and get bigger, and all of that growth area, a lot of that growth area on the second picture is not there. It is dead. It is not expanding anymore in a way that would be regenerative, and that's less than 6 months away from the original picture. Certainly, by now there's even less there. You'll also notice the difference between 2016 and 2017 in that picture. Note the significant reduction in that vibrant green you see in the upper right-hand corner of the 2017 picture. There is a whole lot less of that color green, of that growing plant that's happy kind of green. It's very different on that picture compared to the others. It's a troubling phenomena, as with a lot of this stuff. Additionally, then, let's talk about the secondary effects. We're talking about loss of forests, right? Loss of forests, again, where do you draw the line? Is this a primary effect or a secondary effect? But as unfortunately, those forests get destroyed, definitely a secondary effect is increased chance of disease, and some of those diseases could become pandemics. COVID is in all likelihood the first of many pandemics we're going to have to deal with in the coming centuries. Now, it is very good that we have learned how to cope with that kind of issue, and the lessons that we have learned during COVID, which again, I hope I'm wrong here. There is a distinct possibility that future pandemics could be deadlier and worse, but we have learned very valuable lessons in how to contain things, how to develop vaccinations quickly and distribute those vaccinations quickly. Those lessons in future pandemics are definitely going to save almost probably innumerable lives. And then additionally, to go on the other hand, though, there's a distinct possibility that maybe COVID is as deadly as one of these pandemics can be, because what made COVID spread was the fact that some people, when they're infectious with COVID, feel okay and they just go and walk around in their lives, right? A global pandemic needs that to be able to spread everywhere. A deadlier type of epidemic, potentially pandemic disease, which are hemorrhaging fevers. And if you don't want to go too bad into that, don't look at the IMDb on it. If you're familiar with Ebola, that's what we're talking about. Those diseases definitely are much, much scarier on a visceral level, but because they are deadlier, and quite frankly, they're scarier, then they have less possibility to spread. So I guess there's a positive note there, sort of. Additionally, then, another way that pandemics can become more of a problem in in our climate change world is we are going to have more water in places where it shouldn't be. And water in places where it shouldn't be creates a whole new set of problems. All of these are we have a lot of these. That one problem of too much carbon creates this problem, that problem, this problem, that problem. And the too much carbon isn't the only chemical issue we have, but it's the big bad, right? If you have cancer, and you don't get as concerned about this cut you have on your arm, right? Until it gets to be a problem in and of itself. Um, but things like cholera, dysentery, malaria, those diseases still exist. And they still exist in parts of the world that have problems like there are water places where it doesn't belong, right? In places like the United States, places like Japan, uh, Australia, a lot of Europe, we know how to get rid of water where it shouldn't be. A lot of those other places in the world, um, those diseases are still actually an issue, and those diseases in and of themselves are treatable. But if we are living in a world now where other resources are thin, and we all lived through this in COVID, then when resources thin out, then maybe the hospital is less able to take care of your cholera or help you out with your long-term ramifications of malaria. Because I just learned this recently from a friend who travels to Asia and some other places that still do have malaria. And Asia's huge. I shouldn't just say he's going to Vietnam specifically. Um, Malaria is a lifelong illness. If you get malaria, you do get better, but then you have like chronic flares of it as well. You don't want to get malaria. And if a population in society has those chronic flares of malaria and that becomes semi-common, that is yet another overburdening of the healthcare system, which here in the United States doesn't work great in the first place. The systemic problems are very real. Um, Additionally, then, we're not just talking about infectious diseases. We're talking about non-infectious diseases as well. Those of us with not optimally great lungs, I am one of them. Asthma is a disease, and asthma is something that is exacerbated by what are called microparticulates, which are basically those little chunks of carbon that are a little bigger than CO2 or all kinds of other things that aren't necessarily carbon. And that stuff that doesn't necessarily do the other problem carbon things, but when it is inhaled by those of us with asthma, it makes breathing a lot harder. And this is what has created the unfortunately now relatively common asthma action days in the summertime. It's because on those days, when there's increased humidity, hot air is harder to breathe too. And then you add on that water that's in the air, that's harder to breathe. And then you add on those microparticulates. These are the problems that to those of us with asthma become dangerous. And then additionally, as we've already discussed, children who are exposed to environments with microparticulates get increased chances of asthma, another one of our very many vicious cycles. There's not much we can do about these things at the moment, but in the long term, there are things that we can be able to do. So we are talking about this stuff now, I'm trying to not get us all depressed. We're talking about this stuff now so that over the next 30 years, we can try to fix it, right? That's why we're doing this. That's why we're talking about this grim shit. Additionally, then, when there's water places where it shouldn't be, it goes beyond that. Water issues create food shortages, whether it's floods and too much humidity. Well, that creates illnesses in plants, and that creates famines when a crop is messed up, right? Probably one of the more infamous crop failures in human history, or at least modern history, was the Irish potato famine, in which a particularly virulent type of fungus basically destroyed the potato crop in Ireland. And because those potatoes were grown in relatively close proximity to each other, and this was really the first time that this happened in the modern kind of industrial farming world, then it just decimated everything. That in all likelihood wouldn't happen today because of slightly different farming practices with potatoes specifically, but that's not to say that it might not happen with, say, the corn production in the United States. And corn production in the United States is a colossal portion of total our total calories, not only in the United States but around the world. That would be near catastrophic in that regard. There's a lot of things that could go wrong. But then on the other side, then we're talking about water in places it shouldn't be. We're also talking about water not being places where it should be. That then creates drought, and that can create similar famine issues. Additionally, then, if we have water where it shouldn't be, then we have water that could potentially be being in conflict over, right? This image is a little bit hard to understand, but it is generally addressing where is there going to be water, where are there going to be water issues on the planet? We see in those red areas, those are places where there are going to be increasing water shortages. So we see some of that along the northern side of India, in Saudi Arabia, and some in what looks like the Baja California area. There are going to be kind of moderate issues in the United States anyway, closer to the Rockies in the Midwest. So your Colorado, New Mexico may be in there. It's really small from the view I'm seeing, and some other places. But then don't underestimate those blue areas too. That area is actually going to have maybe more water than it used to have. Now, in Australia, that could be a good thing, maybe. But there are certainly areas where, if notice on the eastern coast of the United States, that is where our climate change issues are going to be the very worst in our country. So that blue being there is not a good sign. That blue being there doesn't mean there's plenty of water. That blue means there's going to be too much water. And additionally, then, with water problems, there will become food problems. There will become viable land. There will become housing problems. There will be more issues we will have to deal with than we did in the past. Additionally, when people have to move around, when people have to be able to take care of themselves, it's important to remember that when people flee one place, they have to go another place. And people very rarely, when they flee, go somewhere that's empty. So those people come in conflict with other people. We saw kind of the result of this sort of thing during the Syrian refugee crisis of 2011. During that time, we saw massive numbers of people move over land areas, and we often mistakenly think that the Middle East and Europe are physically separated. I mean, they can be far away from themselves, but it's all one colossal landmass. So what we had was a influx of refugees from Syria moving into Europe, and that created many civil unrest issues. It created extremism in politics. Most of the phenomena, if you're familiar with the English phenomena that was Brexit, that was really sparked by the fact that there was an increased immigrant population. And this is a founded prediction, but I am pretty darn sure that the way we talk about immigrants today in the United States is going to start also getting applied to climate refugees. So people from areas of the East or other areas that get flooded, what's going to happen when the people that are new here, that some people are afraid are going to be taking their jobs, what's going to happen when those people are American citizens and are coming from a place that is the United States? Is that rhetoric going to be as ugly as it is when before we perceive them as being someplace very different from us? It's going to be something we're going to have to deal with. And it's sociologically interesting, but it's also kind of scary to think about. Additionally, then, those populations tend to move from poorer areas to rich areas. So when they arrive, it puts strain on social welfare systems, it puts strain on infrastructure, on economic systems, and it does have a very real effect on political stability as well. And political instability can create good, positive change, but it can also create very dangerous change. And in some areas of the world, it could maybe put extremist leaders into place as well, which creates another set of issues. And all of this is why we need to work on what's called normal environmentalism. Normal environmentalism is the idea that we are acknowledging that the world is hard, and the world is hard today, and it's only going to get harder. So if we are going to build and continue in actually trying to fix this planet, which it is forever going to be different after climate change, but different does not inherently mean terrible. It could be, but it does not inherently mean terrible. If we are able to adapt, as our species is very good at, we are going to need to create normal environmentalism where the environmentally beneficial thing is the easiest possible thing to do. This is one of the reasons why I think single stream recycling is amazing. Now, at its most basic, and this is how recycling works in Columbus, most major metro areas, they don't make us sort our recyclables anymore. We just throw it all in one bin. That's because that's a step toward normal environmentalism. There are some parts of the country that are trying to figure out how do we mix all of the garbage together, and we just have people throw their garbage away the way they used to before recycling, but then when it gets to the recycling plant, then we're able to just get the truly unrecyclable stuff out of the recyclable stuff and make it so that everyone by default just recycles anyway. It's a great example of normal environmentalism. There are still some major hitches in that vision. There are some places in the country that are claiming to be doing that right now, and at the work, if we truly trust them, the companies saying they are recycling in this way, and I trust most of them, they're exaggerating a bit to us in terms of how much of their actual waste is getting recycled. But it's a good trajectory. It's something to work toward, and I'm fundamentally in favor of it because we got to. But we come to the question, why is this so hard to understand, right? Why do we have to keep having these conversations of you can't do that with... I have this conversation with my father all the time. You can't burn your paper in the backyard the way you did when you were a kid. That's a bad thing to do, right? Well, the fact of the matter is that while we humans are incredibly adaptable, we also have a hard time seeing the big picture. And it's important to always remember that we today are essentially the same animals as those humans that lived about 150,000 years ago, right? We are fundamentally as human as cavemen were, right? The difference between us and those people who came before is because we have been educated to a high degree, and we have enough food, and we have shelter, right? They did not have those things, and that would be the advantage we have over them, but that did not mean that they were worse at perceiving their surroundings, right? Similarly, it means that we, with our biological senses, are not better than them at understanding our surroundings. We have the same sensory organs that we used to. But regardless of our education, we continue to understand, um, to misunderstand things like fire, things like scale, and things like time. What exactly do I mean by this? I'll talk about that in the coming slides. But misunderstanding these things really cause us then to, as a whole, not understand what's happening with climate change. For example, we almost on a evolutionary level, we understand wood fire very, very, very well. We, to use a term from, it's a fringe word, but it is a dictionary defined word, we grok fire. We implicitly understand fire. We get it, we know what to do with it. We know how to cook with it. We can be easily taught how to make it. We get wood fire. We do not grok the fire that comes out of internal combustion engines. We do not get that fire is, and the smoke that comes off that fire is inherently different than the actual fire. We might understand it on an intellectual level, but we don't really get it on a implicit, this is part of my body type understanding. Similarly, it might not be possible for humans to truly understand the raging billions of degrees hot, I don't know if it's billions, but it's definitely millions of degrees hot fire of the sun, right? It is incomprehensible in terms of human understanding. It's just hotter than, our bodies would incinerate at around 1,000 degrees, right? So what does 1,000,000 degrees mean? It's not within our realm of understanding. It's just too much, right? So we don't understand internal combustion, and we certainly don't understand the nuclear fusion that's occurring billions and billions and times every second on the sun. We just and sometimes, like, little kids will think, oh, the sun is a fire. Well, sort of, but it's also millions of miles away and bigger than you can possibly imagine. We don't get that. Similarly, then, it's easy to not understand that modern wood-burning stoves are actually a hell of a lot better for the environment than your electrical heater that takes its energy from coal that is being burned maybe hundreds of miles away from where you are, right? We just don't put that together. We think, oh, electricity, this isn't making smoke right in front of me, so it must be better for the environment. Could it be coming out of solar? Yeah, that'd be great too. But as we continue to be in a world that is overly reliant on coal, really, modern wood-burning stoves are quite frankly better. And so now let's talk about scale. We understand our micro level surroundings very well, right? So the caveman, cave woman, cave person, whoever they are, the caveman understood there's a wolf over there. That wolf is hungry. I'm going to stay away from that wolf so they don't eat me. We, in the modern world, understand there's a car over there moving very fast. That car may hit me. That's the same general mechanic, right? That's over there, I see it, I need to stay away from that to keep safe. But what we don't understand is macro level social interactions. Our ancestors did not understand really, and maybe they did to a certain degree, but their mass migrations, they did not think I am part of a larger body of humans who is also moving away from this place where maybe there's a drought or a famine or a fire or wherever, and we're going to move somewhere else. But millions of people moved thousands of miles in huge collectives, not really knowing where the group of people were going, right? In these mass prehistoric migrations. So they understood, yeah, we're going to walk from here to over there, and maybe in a couple weeks we'll get someplace where that isn't horrible, but they would not have been capable of comprehending the biggest picture of it all. Similarly, in our modern era, it is very easy to misunderstand the stream of migrants over the US-Mexico border as people coming from Mexico over the border. That's just the end of the journey for most people, right? Or sort of the end. Really, many of those people crossing over that border are coming from many different countries in South and Latin America, right? Just because you pass over that border, just because you're Latino, doesn't mean you're Mexican, right? And that's something that a lot of people in American society, they do not get, because they don't get the macro level social interactions. Time is another area where we have issues. Um, Most of us are pretty good at understanding time. I say most of us because those of us with time blindness and ADHD like myself, I don't really understand time, but it's my understanding that most of you do. So in terms of thinking about our personal experience, in terms of hours, years, decades, we broadly understand that because we've experienced it. But when it gets past a human life, it gets harder to comprehend, right? What does it mean that my ancestors came to this, most of my ancestors came to this country as German, what would even become German immigrants? They weren't German yet, about 8 generations ago. That's like 400 years we've been in this country, right? My ancestors. That is so hard to really comprehend. Or what does it mean in terms of a millennia ago? What would life have been like in the year 1224? What does that even mean? What would you be wearing? What would a person that looks like you even look? Would there be people who look like you? That's different for all of us. And then what does it mean in terms of geological eras, right? We are in this Anthropocene era that is defined by the existence of humans, and that was initiated in about the mid 20th century. And that is a colossal difference that means we have fundamentally changed this planet. And those couple sentences I just said barely scratch the surface of what that means, because geological eras are incomprehensibly long in terms of millions of years and sometimes billions of years. And these words are, if and I'm thinking about the active, I barely understand that, right? And I understand it in an academic sense, but to get it, to grok it, it's not even really almost possible. Maybe there's some geologists that do, but I certainly don't. And as a result of these inabilities to understand time, we suffer from this phenomena called contemporocentrism, which is our inability to consider the long-term ramifications of our actions. People often say not hyper intelligent things like, well, I'll be dead by then, who cares? Or, well, slavery, it was a long time ago. Well, thanks a lot. You're going to be dead by then, but what about those other people that you are by definition oppressing by acting irresponsibly now? Or, yeah, slavery was a long time ago, but there are still people in the United States and other parts of the world who are suffering because of social structures that were put into place because of slavery, as a result of slavery, maybe not super direct, but definitely tied to the structures of slavery. And those are real, and that's not fair. And where a lot of our issues surrounding race in our country are tied in with those inherent unfair structures. What are we going to do about that, right? That creates big problems. You may be, if you're interested in this big idea of considering time in this bigger scale, the Iroquois concept of 7 generations. It's more than just a paper towel company, paper towel brand that sold at Kroger. 7 generations means thinking about what are the ramifications of our actions, considering 7 generations in the future and then 7 generations in the past. That's what that Iroquois philosophy tries to take into consideration when making decisions for the collective. And it's a very intriguing concept. So let's finish this up by talking a little bit about privilege as it's tied to climate change. So privilege is the condition of being part of a group that enjoys rights, expectations, or benefits that others do not, right? At this point in your education, you probably have engaged in this at least a little bit. Members of minority groups typically are those that have privilege, and people with privilege also, almost by definition, have greater access to money than those without privilege. This is just the basic concept. Commonly discussed areas surrounding privilege are that of white privilege, heterosexual privilege, class privilege. The groups of people who benefit from it are the people who are said to be privileged. But privilege also impacts the way we cope with environmental problems. Is it more environmentally friendly to only eat organic food? Kind of, mostly in most situations, the answer would be yes there. But can everybody afford to eat that kind of food, that environmentally friendly food? No, right? Some people can only afford to eat the food that they get at the dollar store. And that dollar store food, certainly in almost every situation, is not environmentally friendly, and in most cases is not healthy either. It is very hard to be healthy in this country and many other countries if you are poor. And the King Corn documentary that are in our course materials, that talks about that to a certain degree too. So I really strongly encourage you, if you haven't watched it already, to watch that as well. And then, yeah, all of these things, all of these better food sources, they're expensive. And they don't have to be expensive, but our economic system, the way it is lined up, that puts a priority on junk food and puts a priority on fatty meats, etc., that makes things quite difficult. Another example of kind of applied privilege is what can be called an inverted quarantine. So if you are aware that there is maybe something in your environment like unclean tap water, you can only drink, you can protect yourself from that unclean tapped water by only drinking purified water, right? Well, that is something that everybody can't do. There are many people who simply, in their household budgets, can't afford to only drink bottled water because that is another expense that they are unable to absorb. But that has health ramifications, right? If there is truly a danger in the water, if there is truly maybe lead in the water, that can really mess you up in some fundamental ways that will be talked about in lecture 3.2. Thus, you have to put that energy and those resources into it to be healthy, and those are energy and resources that, quite frankly, many people don't have. As I lay out at the bottom, If you want to drink and maybe you want to drink a fancy water bottle brand, that will cost you $12 per day, $84 per week, over $300 per month, and $4,000 per year. It was quite trendy a few years ago for people specifically to only drink Fiji water. And Fiji water was, and it continues to be an intensely carbon-heavy product and actually quite bad for the ecosystems of the Fiji Islands. Please don't use that product. There are so many other bottled waters that, while they may come in single-use plastic bottles, aren't nearly as environmentally damaging as Fiji water is. But if you're in Columbus at this time, our tap water is actually pretty good in most cases, and our tap water does work. It doesn't work in all parts of the country. Okay, and at the end of that kind of mostly on topic slide, we are done here, and I will metaphorically see you next time you watch this.